So yesterday we were having circuit. So here was circuit RC fixed by a circuit, and then you have a RB, and this RB was connected here. Meter में कोई भी resistance नहीं था, simplest biasing. Here we were having capacitors, okay, and here we are applying V input, and we were taking output. Output कहाँ पे ले रहे थे हम लोग? Output we are taking here, collector, okay. Output we are taking here to collector, and here also was one capacitor. So this is C1, so this is C2, and this is the V0, and here we're taking capacitor, okay, and this was plus VCC, okay. नहीं दिख रहा है क्या VCC? Okay, चलो यहाँ पे VCC है, this is plus VCC. Now I told you how to do this perform. First you have to perform DC analysis, okay. For that you have to solve the circuit and you need to calculate your IB, okay. Calculate IB, okay. DC analysis. DC analysis means calculate IB, and from IB you can calculate IE, that is beta plus 1 IB, and once you know the IE you can calculate RE, that is 26 MB upon IE, okay. And then once you completed DC analysis, okay, you need to perform AC analysis, and AC analysis, okay. So DC, this will be open, capacitor will be open, okay, and AC analysis, this capacitor will become short, okay, and you have to DC जो battery है, that you need to make that as a grounded, okay. And then we yesterday made equivalent circuit. So equivalent circuit was like this. We were having RB here, okay, and then your transistor is simply this diode, okay, and this is replaced by a resistance beta RE, okay. This was replaced by resistance beta RE, okay. Here we have V input, okay, here we have a V input, and outer part I told you, so this current is coming I naught, here current is going IC, they may be same also. So you have replaced what we done, we have replaced outer side this with a current source, okay, that is beta IB, okay, and this is your ground, and here you have put one resistance of R0, okay, and this is also grounded, so you have put RC here, okay, and we know the current flowing through RC is I0, and here we are taking V0, here we are taking V output at this side, okay. So this circuit we have done yesterday, okay. Now we want to calculate the amplifier parameters, okay. So Z input. So we have seen yesterday Z input is simply, okay, what you need to do when you're calculating input resistance here, but in these terminals you have to make open everything, okay. So this is the open, so open circuit voltage you have to calculate, okay, and this is once you open, okay. This circuit is totally isolated from input, okay. This circuit is totally isolated from the input. So when you calculate this V input, that is simply combination of RB and beta RE. So this is your RB parallel beta RE, okay. Or you can directly see what is the input resistance. So if you want to calculate, you can calculate like a VI upon II, okay, ZI, like yesterday you calculated, okay. So if you want to calculate what are II, okay, so this is I input current. So I already know this current is IB. this current flowing through the resistance is IB. Okay, so by doing back calculation, I can find what is I naught. Suppose I want IB. If total current is I, so this will be equals to total current into resistance of RB, and total resistance RB plus beta RE. Okay, from doing back calculation, I can find IE. IE is nothing RB upon RB plus beta RE. Okay, and once I know this IE value, I can find ZI. Okay, ZI is simply VI, VI, and this one. So this become your what? VI. Okay, VI is nothing IB into beta RE. Okay, either this one or this one, same. So I know this current, so I'm taking V input like this, and II is your RB. Okay, is that correct or not? II is your this is I RB upon this is I beta. Okay, sorry. So if I want RI, so II will be IB RB plus beta RE upon RB. Okay, and this value you put here IB. Okay, RB plus beta RE. So RB will go up. Okay, IB cancel. So this is just a combination. This is a parallel combination. Okay, so this is what this was we have yesterday calculated. This is a Z impedance. Okay, this is very simple. Once you draw the equivalent circuit. Okay, then this all the things very simple. So ये हमने कल निकाल लिया था. Okay, similarly we have calculated your this one V naught on Z naught output impedance. So output impedance V naught or output impedance Z naught. So you want to calculate Z naught. What is the here? So simply you need to make this zero. Everything if this becomes zero, this IB zero, you make the source open. So once this is open, only there are two resistance in parallel. Okay. So your Z naught was simply your R naught upon RC upon RC. Okay, the parallel combination of this one. And if you want to calculate, you can calculate like this: Z naught V naught upon I naught. No, this will be I naught will be this time zero, because you make once this make open this is zero, so you have to calculate like this only. Okay, so this R naught RC. Now next parameter was your voltage gain AV. Okay, so voltage gain AV is nothing V output upon V input. Okay, so V output, this is your IC current or beta IV current is flowing. Okay, the equivalent resistance, if you make equivalent resistance this one, then if from this equivalent resistance beta IV current is coming here. Okay, this I naught current coming. So if I make equivalent resistance this one, then current is, which coming here, this is IC. This current is coming from this equivalent resistance. Okay, so simply if you want to write V naught, that will be your, I'm measuring V naught like this, and current is going opposite, so that will be minus, okay, beta IB into equivalent resistance of this one R naught RC. Okay, and divide by V input. You divide by V input. So V input is just now we have seen, that is IB beta RE. Okay, so IB cancel, beta cancel. So your AV is simply R naught parallel RC RE. Okay, so this factor you have to remember. Okay, now the next thing is your calculation of gain. Okay, current gain. So current gain is nothing, your I input upon I input. Okay, this is RC R naught RE. Okay, now I naught upon this we need to calculate current gain AC. So I naught can be calculated from this circuit. इसको रब कर रहा हूँ, ये तो कर दिया हमने. So if you want to calculate I naught, so I naught is simply what? I want to calculate this current, I know total current. Okay, So I naught will be simply total current IC into what? If I want current in this resistance, I need the resistance of this one. So R naught upon R naught plus RC. This is your I naught value. Okay. And similarly, if you want I input, okay, so I need to find IB. So just now we calculated IB is your simply total current I input into resistance of this one RB and beta RE, RB plus beta RE, RB plus beta RE. Okay, so from here I have I input equals to what? That is RB plus beta RE upon RB into IB. Okay, I just take the ratio of these two things. So if I take the ratio of those things, AC, okay, so AC will be ratio of these things. So IB, what is here? This is what? I naught. IC is your beta IB. Okay, IC is your beta IB, and minus is also there. So this will be minus beta IB R naught plus RC. Okay, divide by I input, that is your RB plus beta RE, okay, IB into RB. Okay, so if you solve this one, IB cancel, you get minus beta RB R naught RB plus beta RE and R naught plus RC. Okay, so this is your expression for current gain. Now we know the current gain in common ammeter configuration is beta. So this should be almost equal to beta, isn't it? The current gain is beta. So we can, if you do some approximation, if you say R naught is infinite or R naught is very, very greater than RC, then this term RC will be negligible. Okay, then you can get AC equals to minus beta RB R naught RB plus beta RE. Okay, I'm taking R naught infinite. Okay, so this will be negligible. So R naught cancel. So you simply got beta RB. Okay, RB plus beta RE, isn't it? Now, if you want to further, you want to do further simplification. If even I take RB is beta greater than beta RE, okay, in that case I can leave this, neglect this beta, then this RB cancel, so you get AC equals to minus beta. Okay, so magnitude is equal to beta. Sign is just because of phase reversal, common ammeter configuration, whatever you got input, output will be phase. There will be 180 phase difference between input and output. Okay, that's why minus sign comes.
सर सर आईओ निकाला था ना, जैसे आईओ
इसमें माइनस नहीं है, करंट में माइनस नहीं आएगा, सॉरी, करंट तो हमने ऐसे निकाला ना, हमने करंट डिवीजन से निकाला, खाली करंट पे माइनस नहीं आएगा. हाँ बोलिए
सर, एक बार आईओ बता दो. आईओ आपने कैसे?
भाई ये आईओ है.
यस
ठीक है, इसको रब कर दूं.
यस.
भाई टोटल करंट क्या है? आईसी. ये यहाँ पे करंट तो ये हो रहा, आई नॉट आ रहा है, और इसमें ये करंट है हमारा आईसी बीटा आई बी. ओके, ये हमारा आईसी है. अब ये आईसी इधर आ रहा है, तो ये यहाँ से भी कुछ करंट आ रहा होगा, दोनों करंट मिलके आईसी बना रहा था. आईसी टोटल करंट है. ओके, तो जब भी आईसी इक्वल टू बीटा ए बी, बीटा ए बी टोटल करंट है, तो जब भी मुझे करंट निकालना है किसी ब्रांच में, सपोज आई नॉट निकालना है, तो मैं क्या करता हूँ, टोटल करंट बीटा ए बी लिखता हूँ और रेजिस्टेंस सामने वाला लिखता हूँ और टोटल रेजिस्टेंस लिखता हूँ. R0 plus RC, बस ये तो है।
Yes, yes.
तो बस अब देखो जितने भी क्वेश्चन है इसी एनालिसिस के सारे ऐसे ही हैं। अब मैंने एक कर दिया है ऐसे बाइसिंग का, ऐसे डिफरेंट डिफरेंट बाइसिंग आएगी, तरीका तरीका सेम ही रहेगा, कैलकुलेट करने का तरीका सेम ही रहेगा। ओके, तो एग्जाम में सिंपल क्वेश्चन से आता है अभी, जैसे मैंने यहाँ पे तो आई हैव कैलकुलेटेड इनपुट आउटपुट, सो दे विल आस्क यू ओनली वन पैरामीटर, आइदर कैलकुलेट इनपुट रेजिस्टेंस, so you can immediately see circuit can calculate output resistance, current gain, voltage gain. Okay, only one or two things they will ask.
सर
हाँ,
यहाँ पे आरसी अपॉन नहीं आएगा, आर नोट प्लस बी प्लस
कहाँ पे
आरसी?
कहाँ पे भी
यही
इसमें
बात है।
इसमें चाहिए करंट आपको,
हाँ
रेजिस्टेंस
जी,
सामने सामने वाला लेंगे आर नॉट।
सामने वाला
हाँ,
रेस।
और
ओके
टोटल करंट डिवीजन रूल ना,
ओके सर।
करंट डिवीजन। ओके, सो दिस वाज योर फिक्स्ड बायस। ओके, नाउ लेट मी डू, इस पे एक प्रॉब्लम कर लेते हैं पहले इसको। You should know the numerical things. Okay, now you have been given 470 kilo ohm. This is your 470 kilo ohm. Okay, and the VCC is plus 12 volt. Okay, and RC value is given 3 kilo ohm. RC value is given 3 kilo ohm. Okay, this is your circuit. Okay, so you calculate calculate the values ZI. Okay, ZI, Z naught, ZI, Z naught. What they asking? Okay, find ZI and Z naught. And of course, you need to find RE. The first thing is you to find RE. Then you want to find Z. Then you want Z. Okay, assume R naught is infinite. Okay, assume R naught is infinite. Calculate. So here also you can find A, V, R0 infinite. So मैं यहाँ पे R naught infinite दे रहा हूँ, जरूरी नहीं है infinite हो। जब वैल्यू है तब आपको पूरा यूज करना है, वैल्यू नहीं है तब आपको हटा देना है। ओके, एंड द फिफ्थ यू टू कैलकुलेट ए करंट गेन ए आई और ए सी, assuming R not infinite. So first you want to calculate RE. So RE is what, 26 millivolt upon IE. बीटा क्वेश्चन में दे रखा है 100, बीटा is given 100. So first you have to DC analysis. DC analysis में ये गैप कैपेसिटर गैप हो जाएंगे, ओपन हो जाएगा. ओके, you have this circuit. So you want to calculate IB. So IB just what, BCC, this is 0.7, take 0.7 VCC minus VBE upon RB. Okay, VCC is your 12 volt, this is 0.7, RB is your 470 kilo ohm. This will give you IB value, and once you know the IB, you can take beta plus 1 IB, you can find IE value. So IB कितना आ रहा है? So IB should come 24.04 microampere. एक बार चेक कर लो. And this will come 2.428 milliampere IE. Okay, and if I find RE value is your 10.71 ohm RE value. Okay, फॉर्मूला पता ही RE का, आपको ये फॉर्मूला है. You have to calculate like this. 26 divided by 2.4, तो ऑलमोस्ट 10 के आसपास आएगा, 10.7 ओम आएगा. And the next parameters is your ZE. ZI I told you what is ZI is equal to. That is beta RE
पैरेलल टू
parallel RB. ये निकाल लो. तो RB वैसे भी बहुत ज्यादा है कंपेयर टू इसके, तो ऑलमोस्ट बीटा RE के बराबर ही आएगा. सो ये 10.69 और 10.69 ओम आ रहा है, ऑलमोस्ट सेम ही आएगा. इस केस में बराबर ले सकते हो. ओके, किलो ओम. किलो ओम है कि ओम? किलो एम है कि ओम है? ओम है. किलो ओम आएगा. किलो, क्योंकि आपको बीटा RE चाहिए ना, इसको इसको मल्टीप्लाई करना पड़ेगा ना 100 से. So 10.67. So RE is 10.71, and this is your. You can take 10.71 kilo ohm also, beta RE. Okay, if RB is greater than. So if I do this multiply by this one 100, this become 1 kilo ohm. So still 1 kilo ohm also 470 is very high compared to 1 kilo ohm. So that should equal to come only around 1 kilo ohm. So 10 की 1. इसको करोगे 100 से कितना आएगा? मल्टीप्लाई
1071 ओम.
तो 1 किलो आना चाहिए ना फिर.
यस सर, अप्रोक्सीमेटली 1 किलो. तो 1.069 किलो.
अच्छा ये 1.07.
नीचे नीचे
ये 1 पॉइंट, अच्छा 1.06 1.069 है. ये ठीक है. 10.7 अब ठीक है. तो जितना आएगा उसके बराबर ही आना चाहिए. करेक्ट. सो नाउ यू कैन फाइंड गेन एवी. एवी का फॉर्मूला आपको पता ही है क्या है? RC अपॉन आर. जेड नॉट निकालना पहले. जेड नॉट. सो जेड नॉट विल बी सिंपली व्हाट? आर नॉट पैरेलल RC. आर नॉट में इनफाइनाइट दे रखा है, तो जेड नॉट विल बी सिंपली RC. So Z naught is your how much? 3 kilo. And you want gain. Gain का फॉर्मूला क्या है? Gain is again RC R naught upon RE. Okay. And RC R naught, again this R naught is infinite, so this is just equal to RC upon RE. Okay. And RC आपका 3 किलो ओम है और RE आपका 10.7 ओम है. Okay. So you can tell me how much is coming. Gain कितना आ रहा है बताओ. गेन माइनस में आएगा. कितना आ रहा गेन? 3000 डिवाइड बाय ऑलमोस्ट 10, तो 300 के आसपास आना चाहिए. समथिंग 3000 डिवाइड बाय 10.71 कितना आएगा बताओ.
280.
280
280,000.
280 point something ना. How much? Okay,
Yes.
but
One.
one whatever so is coming, this will be your this one. Okay, and now you can find gain also. Okay, current gain. So current gain का फॉर्मूला क्या है? करंट गेन का फॉर्मूला है, you have current gain AI. ओके, इसको तो इनफाइनाइट ले लिया है, ये आर नॉट कट जाएगा, तो AI का फॉर्मूला जाएगा बीटा RB, सिंपली RB प्लस बीटा RE. ओके, सो ऑलमोस्ट 100 ही हो जाएगा, पर चलो मैं RB पे ले लेते हैं हम लोग. RB हमको दे रखा है 470, so 100 into 470 किलो ओम. ओके, and RB is 470 and beta RE is 1.0669. Okay, and beta R is 1 point beta into R. So this is RB is 470 kilo ohm, beta is 100, and RE is 10.71. And tell me how much is coming. कितना आ रहा था? What is the gain? Okay. So this is your 1471. Okay. So here you have 470 into 10 raised to power 5. Okay. And then here you have 470. Okay. Then 480. No, so no, this will become 1000. 1 kilo.
99.99.
471. 471.71 na, into 10 raised to power 3. So, so I have answer 96. You can check what is coming.
99.99.
99. Okay. Whatever. 99 are okay, good. So you can check. So almost will come 100. Okay. So this was your common, this is a fixed bias. Now this method is almost same for everything. Okay. Now I take voltage divider bias. Okay. But you have to draw equivalent circuit correctly. Voltage, then everything is easy. Divider bias. Okay. So voltage divider circuit is given now. You have been given voltage divider circuit. Okay. So you have this RC. Okay. See, this is my IE, and here you have R1, you have R2. Okay. Here I am putting one ammeter resistance RE also. Okay. Now you see what is the effect of putting RE, and then I am taking output again here, and input again I am taking here. Okay. Where you're taking input output, that also important while making circuit. Okay. And here they are putting one capacitor C ammeter across this one. Okay. So this become voltage divider. Here you have VCC. Okay. Now DC analysis we already learned. You can do DC analysis by accurate method or approximation method. Okay, whatever the method is suitable, you can do approximation. You can find the IB value. Okay, so solve with approximate. So solve circuit for DC analysis. For DC analysis, apply approximation method, or you can apply or accurate analysis. Once DC is over, you need to make AC, and for AC you need to make all the VCC. You have to make grounded. Okay, this becomes short. This capacitor becomes short. This capacitor becomes short. Okay, so when this capacitor becomes short, then what will happen? If this capacitor becomes short for AC, okay, assume this capacitor is very low, so this is making short, so this RE will also disappear. That's the important point here. If RE is present, then the equivalent circuit will be different. But since here capacitor is in parallel to RE in this particular case, okay, this RE will also go away. So this is your circuit, your simplified circuit now, because this becomes short. Now you have to make equivalent circuit for this one. Okay. Now this is ground, and they connect. They both are parallel and connected to ground. Okay. So what I can write, V input. Okay. You have R1 and you have R2. This become ground. This also become ground. Any question is there? Ground. Okay. And then again you have to put transistor equivalent circuit. Transistor is this one will be replaced by resistance beta RE. Okay. So this is your beta RE. This resistance. Okay. This connection, this two connections, and you can beta RE and beta RE also. This is also grounded. Okay. And That is also separately. You have a source, this one, this time beta IB. Okay, and if you want to put R naught, you can put R naught, and if you want to put RC, you put RC. So output is same. Output is same. Say current is coming I naught here. Okay. I naught current is coming here, and capacitor here IC current is going inside this one. Okay, so this is IC, which is equals to I naught is coming here. Okay, so circuit is nothing, more or less same circuit what we got earlier. The difference is there only wherever you getting RB. Here earlier it was RB. Instead of RB, you have R1, R2. Okay, so what I can write, now my formulas will be same. For this particular state, if I want to write my Z input, okay, so Z input is same like if I call this R1, R2 is R dash. Okay, if I call this R dash, R1, R2, R1 plus R2. So this was earlier one resistance. This was earlier RB. So just replace RB by R dash. The formula will be same. So now you can write Z impedance like R dash parallel to beta RE. Okay, क्योंकि पहले यहाँ पे था, earlier it only one resistance. Now I am taking equivalent of the resistance. Okay, so all formula just replace, and now if you want Z naught is again same here. R naught RC R naught. Okay, and so obviously gain will be also same. Gain will be also your minus RC parallel to R naught upon RE, because and your current gain for this particular case will be your beta. Wherever RB was there, you put R dash, R naught, RC, and RB की है R dash plus beta RE. That's it. No change. All formulas same. Just replace this one by combination of this one by RB dash, R dash. Now, if you want, you can try. You can try के करोगे. Solve तो जैसे करना है, same ही करना है. Okay. If you want to try this formula, try like home. I'm giving you homework. The same thing. Okay. So, if any confusion is there, any question is there, please ask. Otherwise, हम आगे बढ़ते हैं. Clear? Radhika, Kishore.
Yes, sir.
Okay. So this is simple. Okay, slightly in the beginning you find some difficulty, but once you start doing the AC analysis is very simple. Okay, in exam also they ask very simple questions. So let me give you one problem. Okay. This is given 1.5 kilo, 6.8 kilo, 56 kilo, V input. This is your 8.2 kilo. And here they have put capacitance of 20 microfarad. Okay, this is a parallel, ground on parallel. Okay, this is 56, 16, and the power supply is 22 volt. Beta is given 90. So you want to calculate RE, same thing. R naught you take infinite. Okay, and calculate RE. then Z impedance AV AI. Okay, tell me the values. So you can solve by this by approximation method. So for for DC, this wall will be open. Okay, so this will be open, and here again I'm taking output V naught. Okay, so further for DC I can remove this one. Okay, seems like it is there. So solve this one for RE. So for RE you want IB first. Okay, so this current you want. So you must find this VB. Okay, you assume this VB, IB is 0. So you can calculate what is VB value. So VB value is 8.2 kilo ohm. Okay, 56 kilo ohm plus 8.2 kilo ohm into 22. Okay, so once you know the VB, okay, VB you know, so you can find VE. Okay, so your VB is equals to, so your VBE, okay, VB is equals to VB minus VE, and your VE is equals to nothing, VB minus VBE. Okay, so this will give you VE. Once you know the VE, you can calculate IE by VE divided by this is RE. RE is 1.6 kilogram. Tell me what is RE coming. Value of IE. So this answer I have 1.14 milliampere. Tell me सही है कि नहीं बताओ. And beta is given 90, so you can calculate. So R first you RE. So RE is 26 millivolt upon 1.41 milliampere. Okay, and this answer I have around 18.44 ohm. 18.44 ohm. I'm giving the answer. You send me as a homework by calculating. You just send me the homework. So I'm giving the all approximate values. Okay, not necessarily these values are correct. You just have to tell me approximately same should come. So I am writing now ZI value. ZI value is with me 1.35 kilo ohm. Z naught I have 6.8 kilo ohm. Gain I have minus 368.76. Okay, and current gain I have 73.04. Okay, so this is a value, please note down and solve it. This is simple calculation है, इसमें अभी time ज़्यादा नहीं सकते हम लोग यहाँ पे. Okay, so I'm stopping here. Okay, this is time for next class. After 5 minutes we'll start next class.